Yo, what's up? Welcome back to another episode of How to Geometry. In this video, we're going to dive into the magical world of the unit circle. It's a foundation of trigonometry, a circle with radius of 1 unit. It's packed with infinite possibilities, and understanding its angles, coordinates, and trigonometric functions opens doors to a realm of geometric exploration that you don't want to miss. So buckle up, get ready to navigate this circle of wonder, and let's embark on this mathematical adventure together. Let's get it. All right, so the unit circle. Intro to the unit circle. I think it's best to start with the special right triangle cases. So if you recall that the two special right triangle cases are the 45-45-90 triangle and the 30-60-90 triangle. So when you have a 45-45-90 situation, whatever the legs are, like whatever length the legs are, they're going to be the same, obviously, because it's isosceles right triangle, right? The legs are equal. Then the hypotenuse is going to be the leg times root 2. So likewise, if you know the hypotenuse in a 45-45-90 triangle and you want one of the legs, you simply divide the hypotenuse by root 2. Divide by root 2. Multiply the leg by root 2 to get the hypotenuse. Divide the hypotenuse by root 2 to get the leg. Okay. The 30-60-90 case, if I know the short leg, then I'm going to multiply the short leg by 2 to get the hypotenuse. Likewise, if I want the short leg and I know the hypotenuse, I'm going to divide the hypotenuse by 2. Remember that, divided by 2. If I want the longest leg, not the longest, the longer of the two legs, right? Because the hypotenuse is the hypotenuse and the legs are the legs. There's a short leg and a long leg. If I know the short leg, to get to the long leg, it's the short leg times root 3. Likewise, if I know the long leg, then it's going to be the long leg divided by root 3 to get to the short leg. So these are the two rules that we learned. If you don't know what I'm talking about, there's definitely a video on how to geometry with the special right triangles. You can look that up. But these are the two cases, right? So let's modify this slightly. And we're going to use those rules to figure out the special right triangles cases, but for hypotenuse is equal to 1. So the hypotenuse is equal to 1 in a 30-60-90. The short leg is always opposite of the smallest angle. So across from 30 is the short leg. Right, across from 30 is the short leg. So I'm going to take the hypotenuse and divide by 2. Okay, if we have the short leg and we want the long leg, then we have to divide by, or we have to multiply by root 3, right? Short leg to the long leg, we multiply by root 3. So this is nice. This is going to be root 3 over 2. Okay. For the 45-45 scenario, again, I have the hypotenuse, so I want to divide by root 2. When I do that, we have to rationalize the denominator. And this is going to be root 2 over 2. Since the legs are equal. Okay, so technically you won't have to do this every time, right? This is building up to something, right? So don't freak out that you have to do this every time. But even if you did, it's not bad, right? Because we have the rule. Okay. So for the third example, it's basically the first example because the other angle is 60. So it's just rotated, right? This is just 1/2 the short leg, and then the longer leg is going to be √3/2. So these three values, right? 1/2, √3/2, and √2/2, right? Because it's a combination. These are going to be the three values that we're going to be dealing with. So if you look at the examples, right now, if we use basically what we learned in trig, right? In trig, we're taught the acronym, right? SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is going to be opposite over adjacent. So that comes up a little bit later. So, so SOH, sine of 30. So it's going to be opposite over hypotenuse, right? Sine is the opposite side over the hypotenuse side. So looking at the three examples, right, here's 30. So the sine of 30 is going to be the opposite, which is 1/2, over hypotenuse, which is 1. So this is nice. Like the hypotenuse being 1 in all these scenarios, it's nice because anything over 1 is just itself. So really, we don't even care about the hypotenuse at this point. So sine of 45, if this is the 45-degree angle, is going to be opposite over hypotenuse. Again, √2/2. 60, you can probably see where this is going. This is going to be √3/2. Okay, same idea, but for cosine. Cosine is adjacent over hypotenuse. Again, the hypotenuse is 1, so we don't really care about that. So in a 30-degree angle, so cosine of 30, so in the first example, we have √3/2/1. Again, I don't care about the over 1. So cosine of 30 is basically √3/2. Cosine of 45, same idea. Adjacent over hypotenuse, √2/2. And then lastly, cosine of 60 is going to be 1/2 over 1. So 1/2. So see how easily we can get to the sine or cosine of one of these three angles, 30, 45, 60. Okay, so I think this is a good segue into what the unit circle is, right? So if we take and if we look at the coordinate plane, right? If this is the x-axis and this is the y-axis, and we take the 30, 60, 90 triangle and set it at the origin, 0, 0, one vertice, the 30-degree at the vertice. So the long side, this was √3/2, and this was 1/2. So what this is saying is point A has a coordinate, right? An x comma y, right? Some x length and then some y length. So the x length is going to go this direction. So it's the length of the long side. So √3/2. And then the height, how far up it goes in the y direction, would be 1/2. So the coordinate for point A, and that's what it's saying right here, to use the length to the sides of the triangle. So the coordinate is going to be √3/2, 1/2. So we can do this for both triangles, right? In fact, the 30, 60, 90 triangle can be oriented two ways. So it's the two triangles, but the three different scenarios all lined up on the origin. And what happens is that for B, the 45, 45, the X direction, right, and then the Y direction. So the length of the 45, 45 triangle is root 2 over 2, and the height is also root 2 over 2. Therefore, the coordinates is root 2 over 2. And then lastly, the 30, 60, 90 triangle, but just standing upward. This is going to be, so this was 1/2, and this was root 3 over 2. So the X direction is 1/2, and then the Y direction is root 3 over 2. Right, so those are the coordinates for the other vertice. All right, why is this significant? Because notice in every scenario, the hypotenuse is 1. And it creates a circle that has radius 1. So we have a circle that has radius 1. So this point right here would be 1, 0. That's a pretty important point. This is going to be 0, 1. Here's -1, 0, right? Because we're going in the negative X direction, right? Negative numbers are to the left. Then this is going to be 0, -1. So we have this circle around the origin, 0, 0, with radius 1, using the special right triangle cases. So we know these 3 coordinates for sure, without a doubt. We know these angles. So what's happening is that we have this circle. It's called the unit circle. What it is, we can add it to our arsenal of tools. So when I say tools, I mean, think of things that we use to measure, right? We use a ruler to measure in centimeters, inches, and feet. Well, the unit circle, in a sense, measures angles, almost like a protractor. But a protractor measures the degrees, right? It measures the degrees. The unit circle doesn't necessarily measure the degrees, but it tells you the X and Y coordinates of the degrees. In fact, the X and Y coordinates have to do with sine and cosine, as you saw up here in the examples, right? Cosine and sine of 30 both have some increments. So once we start building the unit circle, I think it becomes more clear. So let's start with the first quadrant. So the idea is that if we can remember, and I'll show you the little tricks in the end. So this point here is 1, 0. Right? That's because this, at the end of the day, is the x-axis. Right? That's the x-axis. And then we have the y-axis. So one thing is that how a ruler always starts at 0, and typically the ruler 0 is to the farthest left, right? You have some ruler. Is this a good example? Oh, because there's no n. Oh, dang it. Okay. A ruler starts at the far left at 0, right? Well, the unit circle starts at the 3 o'clock position, right? 3 o'clock, because if you think of how a clock looks, right, there's 12, 3, 6, and 9. 3 o'clock is the most right number. Okay, that's equivalent to right here. So what I'm saying is that we got to start the degrees somewhere, and you start at 0, and then you count upwards. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. So we start at 0, and we count upwards, or in this case, counterclockwise. So these are the positive numbers. So if you think about it, there's gonna be little tick marks that you don't see. 0, 1, 2, 3, all the way up to this first line, which is in fact 30 degrees. So if you notice, 30 degrees, we said it was root 3 over 2 and 1/2. Those were the coordinates. Okay. As we keep going, right, that was this first spot. So the next line, we can use a different color. The next line is actually 45 degrees. And 45 degrees, the coordinates are root 2 over 2, root 2 over 2. That line is horrible. Okay. Moving right along. The next line we encounter is 60 degrees. And this is going to be 1/2 root 3 over 2. All right, so what's happening is that these increments, or these lines that are on the unit circle, these are the most common, most known angles, right? And it's because of this fact right here, that because 30, 45, and 60, sine and cosine, are easily attainable, that we can put them on the unit circle as such. Now, in this class, or in these videos, we're not going to, because there are other angles in here, right? 20, 35, 40, 50, 55, 75, that definitely have a sine and cosine, but we don't go into that just yet. This is just the introduction video, so we're looking at the most common. The same way on a ruler, the most common tick marks are like eighths, quarters, and halves. Okay. Here we have 0, 1. So now, all right, so if we look at the second quadrant, we can still make the most common angles. The only difference is that because this is a coordinate plane, to the left of the origin, right, to the left of the y-axis, x is negative. So what ended up happening is that whatever coordinate we have here, that's the coordinate that's going to be here. The only difference is the x is negative. So what I'm saying is this is going to be one half root 3 over 2. Now remember, I just said that the x's are negative. And then you can do this for all of these. So this is going to be root 2 over 2. The x is negative. And then root 3 over 2 and 1/2. And then the x is negative. So now, one may argue, or right now you're probably thinking like, dang, I'm going to have to remember all this. Not necessarily. There are some little tricks that I can show you to help ease the memorization part. So one thing is that as you're looking here, as long as you can remember, so what I want you to remember is that this point is 1 comma 0, right? This is 1 comma 0. And that's important because if you notice, if you look at the y coordinate, which is 0, right? And then you start to count upwards. It's 0, 1, 2, 3. So 0, 1, 2, 3, as far as the y's are concerned. And the same idea with the x's counting down from 0, comma 1, right? If this is 0, comma 1, and we count down 0, 1, 2, 3. Now, obviously, 1 over 2, root 2 over 2, root 3 over 2, right? But 0, 1, 2, 3, that's the pattern. All right, second thing to consider is that root 2 and root 2 always go together, and it's always the middle one. So root 2 over 2 goes with root 2 over 2. Like, they're always paired up, and they're always the middle one. Secondly, 1/2 and root 3 always go together. It's just a matter of which one comes first. Well, that's when you go to the trick I just showed you. If I know that this is 0, well, then the 1 or the 1/2 will be the x, right? Because it's the next in line, right? 0, 1. Just like with starting down here, it doesn't matter where you start, right? If you start down here with 0 for the y, well, then the next in line would be the 1/2. So 0, 1. And then if that's 1/2, then root 3 over 2 will go with the 1/2. So there's little patterns that you can pick up on. Okay. So we did the next. So this is quadrant 1, right? This is quadrant 1, Q1. Here's quadrant 2. Quadrant 3 would be down here. So this is Q3, right? The whole quadrant, not just the little slice, like the whole quadrant. And then quadrant 4. Okay, so I'm going to actually jump to quadrant 4 because I want to show something. I want to emphasize something. So we said that we start at 0. We start at 0. And as we go up, we get to the positive numbers. Well, likewise, if we start at 0 and we go down clockwise, right? This is the negative angles. So you're going to be like 0, right? Because we start at 3 o'clock. 0, -1, -2, -3, -4, dot, dot, dot. All the way until we get to 30, right? Because that's the first common. So we can call this -30 degrees. So -30. So I know when you're using a protractor, you're like, okay, well, there's no negative angles. Just like there's no negative distance. Negative in this sense just means down. So do we have to go down to -30? No, not necessarily. We can start at 0 and work our way all the way around until we get there. And it's nice to know that there's 360 degrees in a circle. So if there's 360 degrees in a circle, and I know that this little slice is 30, so if I go all the way around, this would actually be positive 330. So 330 degrees. So depending on what direction you're going, it's either going to be a positive number or it's going to be a negative number. So, and then that even brings up a good example about it doesn't necessarily have to stop at 360 either. You could keep going around infinitely many times and then stop on any one of these known angles. So let's work the coordinates for this. So this is going to be, okay, so whatever this first one is, correct, because this is 30 degrees, then this one's going to be the exact same coordinate. The only difference is now we're below the x-axis, so that means y is going to be negative and x is going to be positive. So this is going to be root 3 over 2 and 1/2. But because, again, we're below the x-axis, the y value is going to be negative. Now, let's think about it for just a moment, right? The middle one is always root 2 over 2. Always. But the y value is negative. And then this one's going to be 1/2 and root 3 over 2, right? It's 1/2 because it has to be opposite of the other one. So the y value is negative. Then we have 0, -1. Okay. And then we can fill in the last one as well. So applying what we just talked about, the easy one, root 2 goes with root 2 over 2, and it's the middle one. It's always the middle one. And it's like, okay, I want to figure out what's the next in line. So if this is 0, then this one's going to be the 1/2, right? Because that's the next counting number. 0, 1. So 1 over 2. And we know that root 3 over 2 goes with 1/2. The same way up here. This is going to be, so if this is 0, then the 1/2 is going to go in order, right? 0, 1. So 1/2. And then root 3 over 2 goes with 1/2. And now remember, left is negative and down is negative. So this quadrant 3, both x's and y's are both negative. Right, because we're left and down now in quadrant 3. Okay, so this is the unit circle. So now what happens is that you can be asked any one of these angles, to figure out what the cosine or sine of any one of these angles are. So the next little tidbit of information I want to give you, which is really going to make life easy moving forward, is that I said that this is the x coordinate to the left and then the right coordinate. So this is x, y. All of these coordinates are x, y, x, y, x, y. Well, you might as well just go ahead and train yourself to think that instead of x, think cosine of theta. Right, cosine of theta. That's not a 0 with a line through it. It's a Greek letter, theta, just like pi is a Greek letter. And associate sine of theta with y. I know there's a bit of a stretch, but if you can do this, right? Because if you think back, to the example, we said that the sine of 30 is 1/2. Sine of 30 is 1/2 because of the special right triangle case. Well, that's going to always be the case. So when you look at 30 degrees, right, the red triangle, 30 degrees, sine of 30 is 1/2. That's the y coordinate. So that's why I say go ahead and just start associating sine with y and cosine with x. So cosine of 45, right? Cosine of 45, which theta is just an angle, right? I could easily say cosine of 45 and sine of 45. But, 45 is too much and I'm lazy. So I like using theta because it's shorter, right? Cosine of some angle, sine of some angle. And in this case, the sum angle is 45. So the cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. And you can do this all the way around the circle. No matter what angle you pick, right? So if I picked, say, like, let's do kind of a tricky one. If I start at 0, I go around, and I stop here. So let's think about that for just a moment. I went around how many times? One whole time. So it's 360 degrees. Then 90. So 360 plus 90. 360 plus 90 is 450. And then I went another 30. So 450 plus 30 is 80. So this one circle and then some is 480 degrees. So what is the sine of 480 degrees? That's the question, right? Sine of 480. Well, think about it, right? Sine means the y coordinate of whatever this line is. Well, we know that this line, if you start at 0 and go to this line, is naturally 120 degrees. Right, it's 120 degrees starting at 0, going this way. I know there's arrows all over the place. So here, let's get rid of some of them. Okay, so it's 120 degrees from 0 to this line. So when you look here, the sine is going to be root 3 over 2. Right? They share the same sign, S-I-N-E. The angle 120 and 480. And then infinitely many times, right? Like if you did another 360 and stopped right back here, that angle would have a sine of root 3 over 2. And you did another 360 and then stopped right here, that angle would have a sine of root 3 over 2. So you can see how interesting this is. Okay, I think that covers the unit circle, right? So if this is explaining what I just said, literally what I just said. So if you want some academic practice, here are some practice problems. All right, so let's talk about this guy. We didn't bring up tangent at all in this conversation. So let's go back to the unit circle. So let's start with the 30 degree. So 30 degree, using SOHCAHTOA, right? If I want tangent of this angle, I would need opposite over adjacent. So in this case, opposite would be, right, whatever this length is, and then over the adjacent side, whatever this length is, right? That's opposite over adjacent. Well, opposite is just the y value, and the adjacent is just the x value. So tangent is y over x. And that rule is a pretty hardcore rule, right? That this comes up quite a bit. So just y over x. And now I know what you may be thinking because there's fractions, but that's okay because all you got to do is the math once, and then this will fall in line. Like all these other values, the way it got filled in, we can actually fill in tangent in a similar fashion. So if I put y over x, 1/2 over root 3 over 2. All right, some nice algebra techniques happen here. Complex right fraction side of a fraction. The denominators match. Two ways to think about it. You can just cancel the denominators, or you can change, flip, right? Keep the 1/2, change it to multiplication, flip this. So this would be 2 over root 3. These are going to cancel. You're going to get 1 over root 3. If you rationalize the denominator, that's key. You're going to get root 3 over 3. And this is a very common tangent value. So we're going to get root 3 over 3. Think about what the next one is, right? Tangent of theta, root 2 over 2 over root 2 over 2. Anything over itself is equal to 1. So the tangent of 45 is 1. And then I'll give you the last one. That's 1. So this is cosine. This is sine. Tangent of theta is going to be, so here we're going to have root 3 over 2 over 1/2. That's going to come out to root 3. Just root 3. It'd be root 3 over 1 technically, but we don't look at the over 1. So it's just root 3. So think about what would happen in quadrant 2. Right? It's the same numbers, except one of them's negative. So that means a negative divided by a positive, or vice versa, is a negative. So it would be the same tangent values, but just negative. And then quadrant 3, you have a negative divided by a negative, so it'd be positive. And then quadrant 4, the same idea. They'd be negative. So let you look at this for a moment. All right. So if you do a couple of these, I can make a video later. But to show you how quickly some of these should go, right? Sine of 45, that's the middle one. So root 2 over 2. Cosine of negative 45, right? Negative angles go down. But at the same time, it's a 45 degree, which is that middle one. So root 2 over 2, right? It's the x-axis, or the x-coordinate, right? Sine, that's the y-coordinate. Cosine, that's the x-coordinate. Well, even if I go down, quadrant 4, cosine x is positive. So positive root 2 over 2. Tangent of 60, that's the one that we just looked at. So 60 degrees, that was the upper one. So root 3. Having this memorized really comes in handy. So root 3. Tangent of 30, that was the first one. Root 3 over 3. Okay. So I think that's good. Maybe you want to see another row? Sure, sine of 60. That's the big one. That's the bigger one. So that's the y value. The y value at 60 degrees root 3 over 2. So this is definitely going to take some getting used to, like some practice. Okay. Cosine of 30. So let's think about this for just a moment without going back. So 30 degrees is right here. I know, so this is where I want you to be at, right? I know that this point is 1, 0. Well, then 30 is the first tick mark. So that coordinate, if I know this is 1, 0, I know this is 1/2 because 0, 1, right? How you count up. And this is going to be root 3 over 2 because root 3 over 2 goes with the 1/2. So this is my x and this is my y. I associate x with cosine. So cosine of 30 is root 3 over 2. That's the logical thought process that needs to happen. Likewise, with cosine of negative 30, for the same reason, I'll use the same picture. We'll switch the color. So negative 30 goes down. Right, negative 30 goes down. And again, this has a x comma y. It's going to be just like the positive version in quadrant 1. So root 3 over 2, 1/2. But because it went down, the y is negative, right? Because y values are negative when you go down below the x-axis. All right, so this is an accurate representation of the unit circle. Cosine is the x value at negative 30. So the x value would be root 3 over 2. Okay, hopefully this helps out. Do I want to do tangent 330? Sure. 330, well, that's just this right here. That's the same red line. So 330, that's the same as negative 30. Right, because even if you started at 0 and you went all the way around to 330, that's the same as negative 30. So tangent is going to be y over x. So I know that I said that this was root 3 over 3 for tangent. Well, this also is going to be root 3 over 3, except with one little difference. This has got to be negative, right? Because you have a negative divided by a negative. So tangent of 330 is negative root 3 over 3. Okay. Again, hopefully this helps someone get through some homework or something. So go ahead and, if you haven't done so already, subscribe. Hit the notifications bell so you never miss a video. Comment, like, comment, all of it. So until next time, peace.